students, today we are going to start with the chemical reactions and equations, types of chemical reactions. In nature, we see different changes taking place in our daily life. In some changes, no new substance is produced. Chemically, the substance remains the same. There will be the change in some physical properties like its color, its state, its odor, its shape and size. These are called physical changes. But in many cases, chemically new substance is formed. Its characteristic is changed. As a result, there will be involvement of energy taking place. Like you see, suppose the milk becomes sour, curdling takes place, rusting of iron takes place, and other many processes taking place in our daily life. These are called chemical changes. Now the process by which chemical change takes place is known as chemical reaction. Now what happens in a chemical reaction? In chemical reactions, the substances which take part are called chemical reactants. In reactants, the atoms of two or different elements are combined together, held together by force of attraction called chemical bond. So, when a chemical change has to take place, then the bond of the reactant molecules is broken, and when new substance is formed, then new bond is formed again. So in this process, the old bonds are broken and the new bonds are formed. So what is chemical reaction? The process of formation of chemically new substance in which the bond of reactant molecules is broken and new bonds of the products is formed is called chemical reaction. So this is the basic definition for chemical reaction. Again, we can say that the process of formation of chemically new substance from the older substances is called chemical reaction. And again, completing the definition I have written here, that is in which the bond of reactant molecules is broken and the new bonds of the product is formed. This is called chemical reaction. Now, students, in chemical reactions, many changes take place. The question arises that how will come to know that whether the chemical reactions has taken place or not? So there are some observations in which, on the basis of which we come to know that we recognize that the chemical reaction has taken place. So what are the characteristics or observations of chemical reactions? So we write here characteristics or observations of chemical reactions. Now students, we see that there are certain, just I have written characteristics or observations of chemical reactions to confirm that chemical reaction has taken place. Like, first we write here change of state, change of state. Second, change in color, change in color. Third, change in temperature. Fourth, formation of precipitate. So change of state, change in color, change in temperature, formation of precipitate, and then evolution of gas. Evolution of gas. Sometimes with effervescence. Effervescence, that is when in solution reaction takes place, then it will come out with in the form of bubbles. So that is, we use the term effervescence. So we see, a student, that the 5 observations determine that chemical reaction has taken place. Now, a student, we see, we can explain one by one all these things. Now here we see, a student, the first is change in state. Now suppose if ammonia, which is a gas, is mixed with HCl gas, then it forms NH4Cl, that is the solid, white, crystalline solid. So this is the change in state. The gases reacted to form a solid. Similarly, like you see, suppose when carbon, which is a solid, is heated with sulfur, which is a solid, then it forms CS2. Now it is a liquid. It is a solution. It is a solid, that is a organic liquid. So this time two solids reacted to form a liquid. Now take one more example. H2 gas is burnt in oxygen gas. It forms H2O, that is liquid at room temperature. At room temperature. So in this part, all the three things, we see that there is the change of state taking place during chemical reaction. Now, second, a student, we take another point, that is the change in color. Change in color. Now, how does it take? It is taking place. Like suppose, a student, in a beaker, suppose we take copper sulfate solution, CuSO4 solution. Now it is blue in color. Suppose when iron nail is added to it, then gradually reaction takes place, and in metal activity series we know that iron is more reactive than copper. So when a nail of iron is introduced in a copper sulfate solution, now it is blue solution, then the reaction takes place. As a result, it forms FeSO4 plus Cu, that is, it turns to green solution. Blue solution turns to green solution, and reddish brown metal deposits. So this time we are observing that there is a change in color taking place. Now take one more example in it. Suppose we burn copper in air. Copper is burnt in air. Now this is reddish brown metal. And when it is burnt, it forms this compound which is black in nature. So in both the examples we have seen that is the change in color is taking place. Clear, student? Now the third one. The third condition, change in temperature. Third, change in temperature. Now a student, in many reactions the heat is involved. That is, in some reactions the heat is produced that will cause rise in temperature. The reaction is called exothermic. In some reaction heat is absorbed causing decrease in temperature, and the reaction is known as endothermic. So here there is the change in temperature. Now suppose we take example of burning of magnesium. Burning of magnesium. Now in this case, a student, suppose this is, we can write in word magnesium reburn. Actually it is the fine scraps of magnesium in the form of ribbon. Now suppose we take a piece of magnesium ribbon. It is rubbed with sandpaper in order to clean its surface, and then the magnesium ribbon is placed with the help of a step that is with the help of any kind of supporting substance, supporting equipment. Like suppose we hold it with the help of tweezer. Now over the burner, flame of a burner, then we see that magnesium start to burn with dazzling white flame and it forms white powder. Highly exothermic reaction takes place, that is, there is very high rise in temperature. Now this is white powder. Now so what do we write here? That is magnesium ribbon burns with dazzling white flame, that is very bright or brilliant flame, dazzling white flame, producing white powder. So here is the rise in temperature. Now many reactions are endothermic, like when calcium carbonate is heated. We will study it in later topic, decomposition reaction. Now so this is the change in temperature. Now again, student, we see here there is another condition, that is another observation that can take place, that is the formation of precipitate. As we know that precipitate, that is when reaction takes place between two solutions and the product formed is insoluble, then it is called precipitate, and the reaction type of reaction is called precipitation reaction. Now in this reaction, suppose we take some examples. Like suppose again this time we take here lead nitrate solution. Lead nitrate solution is taken and potassium iodide solution is added to it. As a result, we see that here precipitation reaction takes place and yellow precipitate of lead iodide is formed. That is lead nitrate plus Ki gives PbI2 plus KNO3. Now here it is colorless solution, and here it is yellow precipitate, yellow precipitate, and all these are the colorless solutions. So when potassium iodide is added to lead nitrate solution, then yellow precipitate is formed. So this is the formation of precipitate. Now take another example of precipitation reaction. Like suppose we take sodium sulfate solution, Na2SO4 solution, and when here barium chloride is added to it, it is also solution. Both of them are colorless solution. Now as a result we see here, that is NaCl plus BaSO4, that is the white precipitate is formed. Means here we see, students, that when we take the reactions between two solutions, then an insoluble product is formed, that is called precipitate. So this type of observation will help us in identifying the chemical change. Now the next example or next condition, that is the fifth, evolution of gas. Evolution of gas. Now there is very simple example. Suppose a student, we take zinc granules in a tube. We take zinc granule in tube and dilute sulfuric acid is added to it. Dilute H2SO4 is added to it. Here we write zinc granules or granulated zinc. Then we observe that bubbles are evolved. These bubbles are due to the evolution of gas, that is when zinc plus dilute H2SO4 reaction takes place. Then Zn plus dilute H2SO4 gives us ZnSO4 plus H2. We see here that a colorless, odorless, neutral gas is evolved which burns in air with pale blue flame and pop sound, that is the characteristic of hydrogen gas. So here we see that when the two substances take part in chemical reaction, then the gas is evolved. So there will be many reactions in which the gases will be evolved. We will study in subsequent topics. So here there were the 5 observations or characteristics which determine that chemical reaction has taken place. Clear, student? Students, chemical reactions require certain conditions, certain supporting conditions in which it can take place. And a chemical reaction takes place when the particles of substances are made to collide with each other, or that is when some energy is supplied to break the bond and again the new bond is formed. So here we are going to study conditions necessary for chemical reactions. Now there are many conditions required. Like you see, the first is that is mixing or close contact. Many reactions take place when two substances are rubbed together. Molecules are brought in close contact, like iodine and phosphorus react together on mixing or on rubbing. Similarly, when lead nitrate and potassium iodide are rubbed together, then yellow colored compound lead iodide is formed. Like you see, suppose we write here lead nitrate and potassium iodide is made to react here, then here it forms yellow colored substance and potassium nitrate is also formed. So this reaction takes place in solution state as well as in solid state, that is when only they are mixed together. Clear, student? Now the second condition required is in solutions. As we know that in solution the molecules are freely mobile. They easily come in contact with each other. They easily collide with each other. So many reactions take place either when the two substances are mixed in molten state or in solution state. Like all kinds of precipitation reaction takes place only in aqueous solution state, because there the exchange of ions take place. As a result, the new substance precipitate is formed. So we write here in solution state we see, that is, suppose NaCl is reacted with silver nitrate, that is they are in solution state. Now it gives us NaCl and NaNO3 and AgCl. Here the white precipitate is formed. Now similarly, student, we see another example in solution state. When ferrous sulfate solution is added with NaOH solution, then again the double decomposition or precipitation reaction takes place. As a result, it forms FeOH whole twice plus Na2SO4. Here dirty green precipitate is formed. So in this reaction we see that the reactants are taken in solution state in order of reaction to take place. Clear, student? Now the next example or next condition is required for chemical reaction to take place, that is the requirement of energy in the form of, suppose, heat. Many reactions take place when the reactant is heated, like in thermal decomposition, in decomposition reactions. Without heating, the reaction will not take place. Means in natural way it will not take place. Like you see, suppose here there is calcium carbonate. When it is heated, then it gives us calcium oxide plus CO2 gas. So this change is taking place only with the help of heat energy. Now similarly, we take another example of it. Suppose when lead nitrate is heated, then on heating we observe that here this product is formed plus NO2 plus O2. Now here this is reddish brown acidic gas. Reddish brown acidic gas is evolved, and here this is yellow substance, yellow residue, which sticks with the wall of test tube or glass apparatus. So this type of reactions, there will be many examples, many conditions, many reactions, but just we are taking some examples to explain the conditions required. Now The next condition for the involvement of energy, that is, suppose we take here the electrical energy. That is, for the electrical energy, the reaction is, suppose, the electrolysis or electricity. Here we write electricity. That is, the reaction taking place with the help of electrical energy. Like in all kinds of electrolysis reaction, the electrical energy helps in breaking the bond and discharging of ions to form the new substance. For example, suppose we take electrolysis of acidified water. Acidified water. Acidified water, because we know, a student, that pure water does not conduct electricity. But when some acid is added to it, then water molecule get ionized and discharging of ion take place. So when we take H2O, acidified water, and electricity is passed, then here H2 plus O2 are formed. So this reaction is taking place with the help of electricity. Similarly, suppose we take another example. When electric current is passed through molten sodium chloride, then it decomposes to form sodium and chlorine. Otherwise, this reaction, that is the decomposition of sodium chloride, will not take place in normal conditions. So here we pass, that is electrolysis of molten NaCl. Now, when electrolysis has to take place, then the reactant or substance should be dissolved in water or it will be in molten state. So again, NaCl. Now this is in molten state, that is in fused state. Electricity is passed. Electricity. It gives us sodium and chlorine, that is greenish yellow colored. Greenish yellow colored acidic gas. Acidic gas is evolved. So in this case we have seen that the reaction is taking place due to the use of electrical energy or electricity. Now the next one. The next condition, that is again according to involvement of energy. Here there is the light energy. Again, this topic will also be studied when we will study the involvement of energy, or that is evolution of energy and other things. Light, like in case of photosynthesis, sunlight, light energy from the sun is used by the plant cells containing chlorophyll to manufacture their food in the form of carbohydrate glucose, and the process is known as photosynthesis. So in photosynthesis we see, that is this reaction takes place. Sunlight, chlorophyll is also essential, chlorophyll. As a result, this reaction takes place. This is the glucose plus water plus oxygen gas is released. So this is a process which will not take place in the absence of sunlight, without using solar energy. Similarly, you see, a student, that is in photography, photochemical substances like silver bromide, silver chloride are decomposed when light energy falls on it. Similarly, in a laboratory, silver nitrate, hydrogen peroxide are stored in dark colored bottle, that is silver nitrate H2O2 decompose when exposed to light. exposed to light, exposed to light, hence they are stored in dark colored bottles. Like you see, a student, like suppose we take silver nitrate. When light or sunlight falls on it, then it decomposes to give us this type of product. So this is taking place with the help of light energy. Sixth, catalyst. Catalyst is the substance which alter means increase or decrease the rate of chemical reaction without its own involvement, without it undergoing any change, in itself. Means the substance which increase or decrease the rate of reaction without undergoing any chemical change in itself is known as catalyst. It catalyzes. Now, according to its function, it may be positive catalyst. Increases the rate of reaction. Like you see, the decomposition of H2O2 when takes place in the presence of MnO2, then the rate of decomposition is increased. Now, as a result, it acts as positive catalyst. Similarly, you take another example. Suppose when nitrogen and hydrogen are reacted together in the presence of finally divided iron, then the rate of reaction is increased. Now here we also use another substance which we will study after that, molybdenum. So these are the positive catalysts. But again you see there is another one, negative catalyst. As the name suggests, it will decreases the rate of reaction. Like you see, in this reaction, hydrogen peroxide is decomposed at faster rate in the presence of MnO2. But phosphoric acid, here is the example of negative catalyst, retards rate of decomposition of H2O2. So in this case, phosphoric acid acts as the negative catalyst. Now here for this one we use term promoter. That is the substance which increases the efficiency of a catalyst. So here you see that molybdenum acts as a promoter because the catalyst is finally divided iron and its efficiency is increased with the help of molybdenum. Hence, molybdenum acts as the promoter. Clear, student? So this is for the catalysts. Now, next condition required for the reaction to take place is the pressure. Some reactions take place when pressure is applied. Like you see here, a student, that is when mercuric nitrate and potassium iodide are, that is mixed in mortar, then a scarlet colored, here the observation is asked, a scarlet colored substance, mercuric iodide is formed. Now, second, in this reaction we see, that is in Haber's process, that is when high pressure is applied, that is the condition is iron as a catalyst, molybdenum as promoter, and 200 to 1000 atmospheric pressure is applied, then this reaction takes place. Again, temperature is also required here, but this is the condition, that is the pressure is required to reaction to take place. If we will not apply pressure here, the reaction will not take place. So these were the 7 conditions required for chemical reaction to take place. Clear, student? Now in next part we will study about the chemical equations.